Hello, I'm Shaun Thomas, and today I'm going to go over my takeaways from the Grissom video lecture 2, as well as walk through the working code from the examples as well. So first of all, so some of the main takeaways I had for this was the I squared C. Basically, it's a communication system that has basically two wires, SDA, which is for data, and SCO, which is for the clock. Um, and the clock just basically controls the timing of the communication. So the M5 has the ESP32, which is kind of like the master controller, and that uses the SCL to choose how to send and read things, and then SDA essentially is the actual information that's getting sent. So basically, each peripheral or controller that's connected to the I squared C has a unique address, and then the I squared C chooses which address to send over SDA and which information. So it basically allows which device gets to communicate. So this way, multiple devices can share the same wires and they won't step over each other. Um, so even though they all may have the same SDA or SCO lines, only the device who has an address that matches will get to respond. So again, all these sensors and controllers can communicate without interfering with each other. Um, so once the device responds, data can flow back and forth over the SDA, and the SCL is like the clock, so that keeps everything synchronized. Uh, and this bus design lets the ESP32 communicate with all the different controllers that's inside of the M5. Um, so I'm going to walk through some of the code that was in the demonstration video. So this is from the first part of the first video from the GVL2 assignment. And essentially what it is, it's connecting the UCNL 4040 to the M5. Or yeah, UCNL. Um, so if go ahead and start the build. Essentially what's going to happen here is it's going to look for the ECNL 4040 and it's going to start it. And what it is, essentially, it's a sensor for light, proximity, and then I guess raw white light. So once it starts building, well, we can look at the serial output. As you can see here, if I turn my camera on, when I put my hand closer to it, the proximity should go up, and light should also go down. If I turn my phone's camera light on, well, it's not letting me to, but if I just cover it up a little bit, the light should go down as well. And then if I take my hand up, you'll see that proximity go down and the light go up as well. Um, Now heading into the next part of the code. This code essentially what it's doing is um, it allows for I squared C to look for all the valid addresses at the STA pin 32 and SCL pin 33. So essentially what happens is that we have all the addresses first of an array that are all false. And then if an address can be found um, through these two pins, it'll be changed to true. And uh, that should allow us to see which pieces of or which controllers inside of the M5 are allowed to talk over um, the wires on the SDA and SCO. Okay, go ahead and run this. Take a look at the serial output. And there's only one device that's found. Um, But I believe if we change the SCA and SCL to 21 and 22, we should be able to see three different things that are able to communicate, if I remember correctly. Check the serial monitor. And then now there's actually four devices that are able to communicate. So that was essentially all of the code and then all of the takeaways that I had from the Grissom video lecture 2.